Today we will start with Woodward-Fisher rules for another type of compounds, that is enones. Enones means that is alpha beta unsaturated carbonyl compounds. Enones means one double bond and ons means carbonyl compound. So in this we will be calculating lambda maximum value for the molecules containing these type of groups, that is alpha beta unsaturated carbonyl compounds. In this is a particular type of compound in which we can say this is a double bond and this is a carbonyl compound. So the carbonyl compound, the next carbon is alpha carbon and next is beta and so on. So it is alpha beta unsaturated carbonyl compound. Alpha beta have double bond, so it is alpha beta carbonyl compound. Similarly in this it's again alpha beta unsaturated carbonyl compound, and in this one more double bond is present which is in conjugation with this value. So these are the compounds in which one double bond is present and one carbonyl compound is present, carbon is present, and both are in conjugation. So in this type of molecules, the basic value for this type of compound is, if it is 6-membered ring and acyclic enone, means alpha beta unsaturated carbonyl compound is present but it is 6-membered ring, so then the basic value will be 250 nanometer. If it is 5-membered ring with alpha beta unsaturated carbonyl compound, then the value is 202. For 6-membered 215, and if it is 5-membered ring then it is 202 nanometer. And if aldehyde group is present, that is in this group if one hydrogen is present, then it will be aldehyde. For aldehydes basic value is 207 nanometer, and for carboxylic acids or esters in which CO in this OH group is present, then it is acid. If OR group is present, then it is ester. So for acids and esters the basic value is 197 nanometer. So we have to remember these values, which are the main values, main basic values, that is parent values, which must be used. And then for other type of conditions, for other type of groups, we add different values, that is different values are added, that is different increments are added. And for this there are double bond extending conjugation we have already done in dienes also. For this 30 nanometers added, same value is added earlier also. And if alkyl group is added or ring residue is present, then we have to consider at what position it is present to the carbonyl group, if it is alpha position or beta position or gamma position, delta position or higher position. So if it is present at alpha position, then 10 nanometers added. If it is presented at beta position, then 12 nanometer, and if gamma position or higher, then 18 nanometer are added. So it matters at what position alkyl group or ring residue is present, and different positions have different values of nanometer. That is, if these groups are present, OH group is present, it will again depend upon the position where it is present. If it is at alpha, then 35 nanometer. If it is at beta, then 30 nanometer. If it is at gamma or higher value, then it is 18 nanometer. So similarly for OR group, these are the positions and these are the values, 35, 30, 17, 31. And then for the OCOR group, we have values alpha, beta, delta, that is 6 only. And if it is chloro, if at present alpha, then 12. If at beta, then 12. If at alpha, at then 15. So similarly for bromo, alpha and beta, alpha have 25 value and then for beta 30 nanometer. And similarly for NR2 group at only at beta position, then 95 nanometers added. If it is present alpha or gamma or higher value, then no value is added. And if it is exocyclic double bond, this already we know, then 5 nanometer will be added. And if it is homocyclic diene component is present, that is diene is also present, homoannular, then 39 extra value is added. So these are the values which are to be added at different positions. We can write the values in the tabular form also. In this, alpha, beta, gamma, delta positions are shown, and various groups have different values. This is also shown, which we have done in earlier slide also. Alkyl group, if present at alpha, then 10 nanometer is to be added. If at beta, then 12. If at gamma, then 18. Then at delta, 18. Same. So different positions have different values for different groups. This we have to remember the values so that we can easily calculate the lambda maximum value, because the calculation of lambda maximum value is very important and it usually comes in the paper. So next is if we take up, we have taken this alpha beta unsaturated carbonyl compound, and in this is our system. So this system will have 215 nanometer value, and now the various other things. So for that we just mention the positions. This is alpha position, this is alpha position of carbon, and this is beta position, and then this is gamma position, and then this is delta position, and so on. So in this system, this is alkyl group attached, and this alkyl group is attached to beta position, and this is another alkyl group which is also attached to ring residue, which is also attached to beta. So to the beta position, one alkyl group is attached and one ring residue is present at the beta position. So there are two for alkyl and ring residue values same. So we have 2, and at beta, for beta we have 12, we have to add 12 nanometer, so 2 into 12, that's 24. So adding 215 and 24 nanometer, it comes out to be 239 nanometer. So this molecule will have 239 nanometer lambda maximum value, and experimental value is 238. We don't have to memorize these experimental values. It is just given for comparison that the values calculated are very nearly same to the experimental values. So taking up another example, in this example we take we note carefully, and this is the basic, or this is the base, but in this double bond is extending, so our system becomes this. Now this is the basic system, and in this will have this alpha beta unsaturated ketone will have basic value 215 nanometer. Now this double bond is extending conjugation, so 30 nanometer will be added for this double bond extending conjugation. Then this is alpha position, and this is beta position, and this is gamma, and this is delta. So in this beta position has one ring residue, and at the beta position one ring residue is present, so 12 nanometer will be added, and then another ring residue is present at the delta position. So at delta position 18 nanometer will be added, and then this double bond is exocyclic double bond to this ring. This double bond is exocyclic to this ring, so for this 5 nanometer will be added. So anything else, nothing. So adding all these values we get 280 nanometer. So we can easily calculate lambda maximum values if we remember the values for the various oxychromes to be added. So taking another example, in this this is example. In this is our system. So it is a diene, so it will have basic value 270 nanometer. Many books are using 240 nanometer, some are using 215, some are using 217. All values can be written. So in this it has used 270 nanometer. If we will take with 214, then it is also correct. So if we are suppose we are using 270 nanometer, and the substituents or groups attached to this system are this one alkyl group, this another alkyl group, this another alkyl group. So 3 alkyl groups are present. So 15 nanometer as 1 for 5 for each, so 50 nanometer, and so adding this we get 232 nanometer. If we will take 215 nanometer, then we will get 230. That is also correct. So and then this is a next example. In this our system is diene, and diene, this is the system, and now this system is diene, but it is also a homoannular ring, and for homoannular ring the value is 253 nanometer. So we are using 253 nanometer, and then this is a alkyl substituent, and this is a ring residue, and this is a ring residue, and this is a ring residue. So we have 3 ring residues, 1 alkyl, that is total is 4, and for each value we have 5, that is 4 into 5, that is 20 nanometer. So 20 nanometers added for ring residues and alkyl substituent. And then this double bond is exocyclic to this. This double bond is present outside this ring. So for this 5 nanometers added, and then everything we have added. So the values after adding comes out to be 278 nanometer. Then similarly in this example, this is our system. It is alpha beta unsaturated carbonyl compound, and now this is alpha carbon, this is beta carbon. So if we see one alkyl group is present at the alpha position, for that we have to add 10 nanometer. Then 2 alkyl groups are present at the beta positions. For beta value is 12, so 2 groups are present, so it is 24 nanometer. And for this basic value is 215 nanometer for the alpha beta unsaturated carbonyl compound. So value comes out to be 249 nanometer, and experimental is also same, 249. So for this we can calculate like this. Then for next example, suppose we have taken this example. In this example, this is a system. This is our system, that is alpha beta unsaturated carbonyl compound, but now it is a 5-membered ring. For 5-membered ring the basic value is different, and it is 202 nanometer. And then for this system, this is alpha carbon, and now this is beta carbon. So now bromine group is present, and bromine group is present at alpha position. For this we have to see what is the value for bromine group if it is present at alpha position, and it comes out to be 25 nanometer. For bromine group at the alpha position, the value is to be added is 25 nanometer. Then now see the ring residues. One ring residue is present, then this second ring residue, and this is third ring residue. That is 3 ring residues are present, and now these ring residues, this ring residue cannot be considered because this is neither it is present at alpha nor beta, neither delta or gamma, so on position. So the ring residues attached to the alpha, beta, gamma, delta position, these can only be considered. So this ring residue is present at the beta position and this is also at beta position. So two ring residues are present and at the beta positions. For beta position we have 12 value, so for 2 we have to add 24 nanometer. Now this double bond is exocyclic to this, so one double bond present is exocyclic to this ring, so 5 nanometer extra is added. So adding these values we get 256 nanometer. So this is a example of compound in which the ring is 5 membered. Similarly in this also the ring is of 5 carbon. So this is a system. For this, as the ring is 5 membered, so it is 202 nanometer. Now this is alpha carbon, this is beta, and one ring residue, then second ring residue. Two ring residues are present and that both at the beta position, so the 24 nanometer has to be added. Now this double bond is exocyclic to this double bond, so we will add 5 nanometer, and there is no group as present in this. Br group was present. Now we have, after adding this, 231 nanometer. And similarly in this example, this is an example of diene. In this is a system and this is a diene and it is a heteroannular diene. For this the value is, basic value is 214 nanometer. Now to this system we see the sides of the ring attached. One is this, 2 and 3. So 3 sides of rings are present, that is 3 ring residues are present. So for 3 we will add 15 nanometer. And now this double bond is exocyclic to this double bond is exocyclic to this, so for this 5 nanometer, and so after adding these values it comes out to be 234 nanometer. So now we can easily calculate lambda maximum value for any diene or for any alpha beta unsaturated carbonyl compounds. Similarly we take up another example. In this example, now suppose this is also a diene, but there is also one double bond present. So first if we consider the base, so this is base but the double bond is extending, so this is a system. And now for diene, and that is heteroannular diene, we take basic value 214 nanometer. Now this is double bond extending conjugation. For double bond extending conjugation we have to add 30 nanometer. Now for two system, the sides of the rings attached touching are 1, 2, 3, 4, 5. So 5 sides of the rings are touching to our system. So it is 5 into 3, that is 15 nanometer. Oh sorry, that is 25 nanometer. And now there's the exocyclic double bonds. This one is exocyclic double bond. This double bond is exocyclic to this ring and also to this ring. So this double exocyclic double bond is present to two rings, 1 and 2. So these two, and then this double bond is exocyclic to this. So there are 3 exocyclic double bonds. 2, these are equivalent to 2, and this is 1. So 3 exocyclic double bonds. For 3 exocyclic double bonds we have to add 3 into 5, that is 15 nanometer. So it has a diene system, so 214 nanometer, 1 double bond extending conjugation, so 30 nanometers added, and then 3 exocyclic double bonds. These are this is equivalent to 2 and this is 1, and therefore 15 nanometer, and there are 5 ring residues, 1, 2, 3, 4, 5, so 25 nanometer. So after adding all this we get 284 nanometer. And similarly in this example, this is our system, alpha beta unsaturated carbonyl compound. For this the basic value is 215 nanometer, and then this is alpha and this is beta. To the alpha position, one ring residue is present, so 10 nanometer is added, and to the beta position also one ring residue is present, so 12 nanometer. And then there is a one exocyclic double bond. This double bond is exocyclic to this, so it is 5 nanometer, and total value comes out to be 242 nanometer after adding all these values. So similarly, taking up another example, in this is our system. So the basic value will be, and it's moreover it is a homoannular ring, so basic value is 253 nanometer. And then this alkyl group is present for this 5 nanometer, and then the one ring residue, two ring residue, and then this is 3 ring residues are present, so this will have 15 nanometer value. And then this double bond is exocyclic to this ring, this double bond is exocyclic to this, so 5 nanometer is added, etc. And then these groups or rings present are not touching to the system, so these groups or these rings are not considered in the main system, and so the value total comes out to be 278 nanometer, which is very nearly equal to